Hello, my name is Brent Peltola. I am the Executive Director of Partners in Research Canada, and I will be your host today. Joining us for this PIR live event is Gavin Tolometti discussing the moon, the Lunar Gateway, and the Junior Astronaut Survivor Moon activity. So a little intro on Gavin. Gavin is a PhD student with the Institute for Earth and Space Exploration at Western University. In 2016, he graduated with a Bachelor's of Science in Geology at the University of St. Andrews in Scotland and moved to Canada right after graduation to begin his research on lava flows. His PhD research involves comparing satellite and radar images to field observations of lava flows on Earth to understand how lava flows work on the moon and Mars. Currently, he studies lava flows at Craters of the Moon National Monument and Preserve in Idaho. And in 2014-15, I'm going to get this name wrong, Lunar lava field in Iceland. So before we get started, I will remind you to open the Q&A window by clicking the Q&A icon in the bottom of the video window. Please use this area to submit questions as they arise, and we will get to them when able. So now over to Gavin.
Hello, thank you for inviting me today, and I'm looking forward to talking to you guys about the moon, the gateway, and the Survivor Moon activity with the junior astronauts. Do that. So, hoping you guys can all see this. There we go. So, with the moon's a really big topic now in space exploration. NASA and all of the countries across the world, including the Canadian Space Agency in Canada, have started to point the direction towards the moon. They're starting to invest more money into returning to the moon, sending the next generation of astronauts and the first female astronaut onto the far side of the moon. And the main reason is because they're treating the moon as a stepping point to going beyond our Earth-Moon system, to going towards Mars to explore and beyond. But before they can do that, they need to be able to test new technology, to be able to figure out how can astronauts survive deep space exploration and travel, and how can we use new rovers, landers, and other new instruments to extract resources that they can use for space exploration without having to rely on Earth resources, which is the really big selling point for the Lunar Gateway. So this is a artistic visual of what the Lunar Gateway would look like. It's a lot smaller than the International Space Station, and a lot of people think it's just going to be a second International Space Station, but just orbits the moon. But it's not really the same thing. The ISS is about the size of a 6-bedroom apartment building. The Lunar Gateway is it's like a fifth that size, so it's a much smaller. And it's primarily going to be used for research and very short-term habitation for astronauts. So to give you some context, the goal for this gateway, every year, astronauts would come to the gateway, but only spend about no more than 3 months on the space station. And for 9 months, when there's no astronauts, the rest of the space station is going to be run by artificial intelligence and advanced computer systems to keep instruments and programs and experiments running. So this is just a configuration concept of like a buildup of what it's going to look like, and it lets you know what space agencies or countries are actually contributing to the Lunar Gateway. So you can see that NASA is the major contributor, it is their initiative. But you've also got space agencies such as ESA, which is the European Space Agency, supplying modules such as the International Habitation Module for astronauts and the Orion Service Module to help it get off of planetary surfaces, mainly Earth and the Moon. And we have the Canadian Space Agency. We will be supplying the Canadarm3, which is going to be used to help construct the Lunar Gateway around the mid to late 2020s. And also to attach itself to modules such as Orion when astronauts and supplies come in, and to also help repair solar panels and capsules from the outside in case the astronauts can't physically reach them. And there are also other space agencies such as JAXA, is the Japanese space agency, and the Roscosmos, which is the Russian space agency. So you can already see there's huge international collaboration already. And this doesn't even include some of the smaller countries that are also involved, such as Australia, some more countries in Europe, and other ones across Asia. So this is just a close-up of the Canadarm3 of what it's planned to look like. And Canada is known in space exploration for robotics and artificial intelligence. That's what they specialize in. So it was no surprise when they announced when they were contributing to the Lunar Gateway, they wanted to supply the next generation robotic arm to help construct the gateway. And it's usually like you always stick with what you're good at, and robotics and artificial intelligence is something Canadian scientists and engineers really strive on. So this is just a good idea of how what it's going to look like when it's finally built. So for the Lunar Gateway, the main thing was to prepare humans for the surface of the moon, but also for a deep space exploration. And the best way to do that is to test new technology, new habitation suits for them to use, not only on the space station itself and in the flight module, but also when they're on the surface. Because during the Apollo era, they discovered that there's a lot about the lunar surface they weren't really prepared for, such as the soil, or what they call lunar regolith, was actually very glassy and sharp. If there's a lot of it and it was coming at very high speeds, could actually penetrate through spacesuits. So they had to think of new material that could help keep them safe from the regolith. And it was also very sticky, because since there's no electrostatic cohesion, which if you guys know, if you get a balloon and rub it on your head, you see how your hair is then attracted to the balloon. That's kind of how the regolith reacts to when it touches the surface. It sticks to you and it won't really get away, which is a problem because the regolith is very bad if you breathe it in or if it gets into instruments, because it can damage the electronics. But then to prepare them though, the best way to do it is to simulate the conditions on the moon and low gravity conditions as much as possible, which is why astronauts are sent underwater to complete tasks, because it's the best way to simulate if you were moving at a lunar orbit where it has the 1/6 the gravitational strength of Earth, or if you're on the gateway itself, where it's like an International Space Station where you're floating around with a lot of resistance. And it's also because since the surface is so hazardous, they have to prepare them. And to do that, they need to be able to put astronauts in the field that on Earth looks similar to this, since we can't go to the moon right now to train them. So in order to do that, to study the moon, we need to study Earth. And it's the best way to understand its surface and its environment. Obviously, with an atmosphere on Earth, we can't get a perfect similar environment to what the moon is, but we can definitely find the landscape and the landscape and the hazards that they will probably approach in the environment that they can find on the moon. And some places that really good locations for training astronauts is Iceland, near the Holurin lava field that I study. And it's got a lot of volcanic soil, and it's very hazardous, very rocky. So it's quite similar to the lunar surface. NASA has sent astronauts up to the deserts in Arizona, Utah, and Nevada to train them in desert-like conditions where there's a lot of sand and loose rock scattered all over the place. And it's also the perfect place for them to test out the new spacesuits that they're going to have on the Lunar Gateway, and also test out the new rovers and robotics that they plan to take up there. And also to do that, because the Lunar Gateway
All right, I don't know if we have
to inspire the next generation and to prepare them for.
So we had a little bit of an audio freeze there, Gavin. If you can back off about 10 seconds in what you said, that'd be great.
Okay, I'll start to the beginning of this slide then.
Sure.
Okay, so and with the Lunar Gateway, NASA has also sent astronauts to desert-like conditions that are kind of similar to the surface of the moon. And they mainly send them to Arizona, Utah, and Nevada, where they get to test out some of the new spacesuits, the new lunar exploration vehicle ideas, which is actually what this is. It's a lunar exploration vehicle where the astronauts can use to travel around the surface of the moon for long-term durations. And I say long-term, it's about no more than 2 weeks or so. And it's also the perfect place for them to test out new instruments that they want to send to the moon and the gateway to collect new science that can maybe answer questions from the Apollo era. But to prepare the next generation, because that's the main thing for one of the big things for the Lunar Gateway, it's inspiring and preparing the next generation for deep space exploration. But to do that, you need to be able to train students of all ages, even from grade 4 up, to understand what it's like to, one, be a part of a planetary mission, run a planetary mission, or the workload involved. Like, how does everyone communicate with each other, especially if it's between scientists, engineers, and within scientists could be biologists and the geologist. So that's why we have these what we call analog missions, which just means you're simulating a mission that would one day be real. So this is one big thing that's happening a lot now in Canada. This is what actually happened this summer at Western University. A team at Western was simulating a rover on the moon collecting samples that would return them to Earth. So everyone each had a different role, which either involved an instrument or planning, and they got to understand how the mission was planned and how everyone would execute it. And just to really point out the big 4 things about the Lunar Gateway is, 1, they want to inspire for future generations, not just to get into planetary science, but to inspire them to pursue careers in STEM. So with science, technology, engineering, and mathematics. Science investigation and missions, they want to be able to push forward to, 1, answer questions that arose during the Apollo era, and to discover new opportunities on the moon, such as extracting water ice from minerals in craters on the far side of the moon, which could help astronauts create rocket fuel and drinking water or breathable air on the moon. And exploration. Humankind's always been very curious about going far beyond what they're capable of, and going back to the moon and then beyond is what's been really driving a lot of space agencies. And 4 is kind of a new one. It's the economy. They want to be able to create a sustainable space economy. And when they say this, it's not to create like a business in space almost, like not like a company. It's more so they can rely only on resources that are outside of Earth for space exploration and not have to rely on resources back on Earth, which can save, 1, a lot of money, and 2, they're no longer reliant on having to send water, new materials, or food up from Earth. So it makes it a lot easier and progresses our innovation from there. And this is actually where you guys can come in. So I mentioned with inspiring the next generation. So that's kind of what the Canadian Space Agency is doing here with the Junior Astronaut program. And their mission is the moon mission. And what this is it gets to shows kids from different grades, from usually grade K to 9, about the lunar exploration, about different tasks and challenges astronauts have to face, and about the different science questions that arise from lunar exploration and what the Lunar Gateway is trying to answer. And the one today that I want to introduce you guys to is the Survive a Moon Challenge. And it kind of goes a little bit like this. So you and your team, they're astronauts for the Canadian Space Agency, and you're currently being sent to you're replacing a crew that's at an outpost on the near side of the moon. So the side of the moon we can see every time at night. So you're going over there to replace them. But however, your lunar capsule goes off course during your descent to the surface, and you land about 50 kilometers from the outpost. In your capsule, you realize you only have 15 items that could help you survive. So as a team, your task for the Survivor Moon is to rank or to decide what items have a bit higher priority than others. So you would rank these items from 1, the most important item, like we need to take this with us, to all the way down to 15, which is like, we don't really need this because it's not really going to help us get to the lunar outpost. So the question is, how would you rank these items? So I'm not quite sure if some of the classrooms have done this. So I'm going to show you the items, and they're not in order. So just to give you an idea of what they look like. So like some of the items can be like a stellar map, which tells you about the stars and the formations to help. Another one is like material from a parachute, a 15-meter of nylon rope, and food all the way down to like food concentrates. So these aren't in order from 1 to 15, but these are the 15 items that you would, as a team, have to figure out. If you were astronauts on the moon, you're 50 kilometers from your outpost, what could help you get from where you landed back to the outpost? Thank you for listening to the presentation, and I'm happy to answer any questions.
Fabulous. Gavin, if you can just click the stop share button at the top of your screen. Excellent. Um, so I love the Survivor Moon activity because I've done it as an Earth activity before. And I think the way you might answer some of those questions would be a lot different when you have 50 kilometers to travel on the moon versus 50 kilometers to travel in the backwoods of Alberta. So
Yeah.
it would be really interesting to see the results of that, that activity. So one of the questions I wanted to get to before we get to some of the questions in the Q&A, and I'll just remind classrooms that are watching, any questions that you had that came up during the session, please just put them in the Q&A window, and we're going to get to those in a minute. So you talked about some of the environments that are used on Earth to simulate the environments in space, and looking at deserts and lava flows and what have you. But when it comes to Canada's contribution, how do you simulate the movement of the Canadarm on the Earth? Is there a way to do that?
As far as I know, I think they mainly do most of those tests in a clean room laboratory where they build it. I think that's mainly they just have to see how it reacts, just how the joints move under certain conditions. I don't know too much how closely they try to simulate like a low gravity or zero gravity conditions, because it's going to be a lot different once they put it up there because it's not feeling any resistance from gravity. But I have a feeling they mainly do as much testing as they can in Canada, and I could be wrong, but I think then they send it to where it gets constructed down at Houston or at the Kennedy Flight Center down in Florida, and they probably do more tests over there because I think NASA has larger facilities where they can test all the equipment.
So we're going to get over to the Q&A window, and this is the question that we get for these sessions when we're talking about space travel. How do you get rid of human waste on the space station?
I think they mainly package everything because they don't release everything out into space because it's just gonna. I mean, space is vast, but we're not really wanting to throw our waste out there. Same way that we don't really want to throw our waste outside when we could just be putting it away properly through pipes. So I think they package everything while they're on a space station, and when either supply capsules come up to give them more material, new food, water, supplies, or when the astronauts have to return to Earth, I think they take all that material back with them, and then they properly dispose of them on Earth.
Cool. So that question was from Mr. Kern's class, and they have a few in the window. We're going to get to a couple of them here. They're asking about the color of moon photos. Why is the moon always black and white? Are the materials of the moon not colored at all?
The only time they've actually found something that's colored is recently, where they found, at first what they thought when they brought them back it was actually Jack Schmitt, the only scientist who actually stepped foot on the moon. Every other astronaut before that had been engineers or pilots. He thought he saw orange soil on the ground and got very excited because they always thought everything on the moon was going to be either white, gray, or black. So it was like nothing very exciting to look at, unlike Earth. But when they brought it back, it was more brown color. But the fun fact about this material that they found, though, it was what we call little pyroclastic beads. So they come from explosive volcanic eruptions. They're a little glassy because they cool very rapidly as soon as they get into the air, or in this case, into space. And these little beads actually contain the first evidence for there was water on the moon, like traces of water, not like puddles of liquid water everywhere, but these little beads had gas chambers that contained liquid. It contained H2O inside. But the main reason there's no any color because just most color we have on Earth either comes from certain elements that the moon just doesn't really have in abundance, from erosion, which the moon doesn't have, except with the exception for meteorites constantly bombarding the surface, and also just from life interacting with it. Like organisms do alter the colors of some rocks. Like when you find moss on some rocks, they make them look very red and brown when originally they could have been white.
Okay, so Mrs. Cam's class has a question that I think fits right in with your background, asking about whether there's any signs of volcanic activity, either past or present, on the moon.
Oh, definitely lots of past present volcanic activity. In the near side, you'll notice how you always see the light and dark coloring. That's usually the big thing that usually pops out, even without a telescope. The darker parts are what we call lunar mare, which are literal seas of lava flows that poured out from the surface and just like covered, usually either giant impact craters, which are larger than 200 kilometers in diameter, or just covering the surface. And because I think currently the mares cover about 25, 30, someone might correct me on this, but 25, 30% of the surface of the moon. And there's also other types of volcanism. I mentioned like these pyroclastics, that's more explosive. Think of like fire. If you see fire fountains in the eruptions in Hawaii, but think of that on a much larger scale, that's kind of what you're looking at. But nothing current at the moment. There have been arguments. I think the last volcanic eruption occurred just less than 10 million years ago, but most of the volcanic activity stopped after 2 billion years.
So just to extend on that question then, is that the same situation on Mars or other planets in our solar system?
It's mainly because it's so small, it's so cold that the interior heat is just not strong enough or high enough to actually allow volcanic activity or processes to occur. So, and Mars is similar, that since it's smaller, it's bigger than the moon, but it's smaller than Earth. So it probably doesn't have the same internal heat anymore to be able to drive volcanic eruptions like it used to. Like that's why Earth is still very active because we've got an active system. I believe Venus is still active because it's the same size as our planet, so it should still be active. But then you got exceptions where you've got Jupiter's largest moon, Io, which is much smaller than Earth, but it's the most volcanically active body in our solar system, more than our own planet. But that's mainly due to the forces between that moon and Jupiter itself that is actually keeping it hot inside. But that's like an exception. But most of the time, it's just because of its size, it's too cold to be able to generate any volcanic eruptions.
Interesting. Shannon Richards' class is asking, how long does training take? So I'm assuming that this is a question about our astronauts, either the Canadian or international astronauts. How much training is involved in this kind of a role?
It can vary. I mean, some astronauts spend like, I think you definitely need at least 5 years, I think, probably more to be able to be ready to be selected to go up. But there are some astronauts that that go through all the training, and by the time they're close to retirement, don't even get the chance to go up into space. I think it was Chris Hadfield that said that. He said there are some astronauts, you go through all the training, the physicals, the mentals, you go through field work, you go through learning all the instruments, you learn the training from an engineering perspective, a scientist's perspective, a doctor's perspective, and sometimes you don't even get to go up. It sometimes just comes down to what missions are happening, what countries are allowed to select astronauts, and then for those countries, which astronauts are ready at the top of their list to be put forward. So it can take years before you're even selected, but it doesn't mean that your skills are wasted. The skills that you learn as an astronaut can be put to numerous different jobs on Earth. So it's very useful skills to have.
And right now in the Canadian Space Agency stream, we have 2 astronauts, I believe, that are in training. Is that right?
They currently there's 4 in total.
Okay.
And there's I can't remember all of their full names, but you have David St. Jacques, who recently came back in the summer. You currently have Jeremy Hansen, who he would be the next person to go up. I think he was in Houston recently. He was doing some training. You've got Jenny Seide. She's currently in training now, but I don't know when she'll be going up. And then there's John, I can't remember his full name, but I think it's John something. And I think he's like, same with Jenny, he's also in training.
Okay. So when we start talking about going back to the moon, it's been a long time since there's been a moon landing. Catherine Orr's class wanted to know about the travel time, moon to Earth, Earth to moon, either direction, I guess.
I think it takes approximately 3 to 5 days. Yeah,
And and that's not something that you can change with the ship you're using, because basically once you leave the atmosphere, you're just using your momentum to move. That's correct?
the only way for it to be faster is you'd have to constantly have a propulsion system pushing you forward. Because since you have no drag at that point, even a small little like burst of energy could just like propel you forward.
Right.
What that is, I am not an expert in aerospace or flight dynamics, so do not quote me on this. But I just do know that if they put more energy in, it will probably change their course, and two, make it harder for them to slow down. Or they'd need more energy to have something go in the reverse direction to slow them down during their approach to the moon. Because if they're going too fast, they might miss it, and then they'd have to redirect themselves somehow. If they're out of power, then that's a major issue.
Yeah, that would be a major issue. No kidding. Rory Whitbread's class is asking why the moon looks the same from any vantage point on Earth.
Oh, that's because the moon, when it takes 27 days for the moon to orbit Earth. But what you also don't know is that when the moon's also rotating just like any other celestial body, but it also takes 27 days for it to do a full rotation. So that means with the Earth and the moon, it's what we call tidally locked. And that means that even though it's constantly rotating, since it's taking the same amount of time to go around Earth as it does for the moon to do one full rotation, you're constantly seeing the same face on Earth. So it is actually spinning. It's just since it's orbiting around Earth at the same amount, the time it takes for it to orbit around Earth is the same. We don't see the other side of the moon. So that's why we always see the near side of the moon.
Interesting. Mademoiselle Keene's class asking, what would happen if the astronaut suit has a cut in it while in space?
Well, it depends they have multiple layers in the suit. So it's not just one layer, because if it was just one layer and one small cut, then they pretty much have to find a way to patch it or else they won't be able to breathe. The outer layer is to help keep the internal material like safe, because that's usually what keeps them warm or cool, depending on where they are on the moon. So if it does get a cut, they will have to find ways to repair it while on the moon or on the gateway. And I know you get a lot of movies where you see astronaut suits, they get cut, they just get some duct tape and strap it on. It's not really the same thing that would work because some of this material is pretty strong. So I don't know off the top of my head some of the kits, but I know that they have emergency kits on hand to help repair suits, because if the suit gets damaged and that's the only one they have, then they can't continue the mission.
Gotcha. So Mr. Cruz's class had a question about gateways, and it's interesting, asking, will NASA make more gateways on different planets or on different places on the moon? So my understanding is the gateway sits somewhere between the Earth and the moon. Is that accurate?
Apparently it's able to change its orbit. The orbit I know it's going to take it first is called the Lagrange 2 orbit, which is actually behind the moon, but it orbits in a way that it can constantly see the Earth as well as behind the far side of the moon, so it has clear, constant satellite communication with it. But to answer will they build more? It will, it probably depend on a few factors. One, the success of the Lunar Gateway, because if it goes smoothly and maybe beyond what they expect, then they've shown that they can build more deep space platforms. Two, it always comes to that question down to funding. That it's not a cheap initiative to start. That they have to build all these new capsules, build the rockets to get them there, and I think if they were to build another one, depending on the success of Lunar Gateway, it would probably be one around Mars, but we probably won't see anything like that until after they've proved they can get humans to the surface of Mars.
That's great. Sorry, I'm just looking through questions. I want to make sure that we get to the ones that are getting asked most often. Question about the lack of air on the moon. So this is the question about, I guess this is about space. Why does the moon not have air?
Oh, it's because it doesn't have an atmosphere. It's it has what we call a tenuous atmosphere, but it's all that is pretty much just some noble gases that are kind of present, but they usually formed from, I think it's interaction with cosmic radiation, solar radiation, but it just doesn't have an atmosphere because its gravity is so weak that it can't hold on to any gases that ever pretty much were emitted or released from the surface. So that's why Earth has an advantage that its gravity can hold on to all its gases in the atmosphere, and that's why we have an atmosphere.
So
It's the same.
the atmosphere encloses those gases then to hold them
Yeah,
closer to the surface.
the atmosphere holds everything in, and the gravity holds in the atmosphere. If gravity was to go, or if also it's because since it doesn't have a magnetic field, cause solar flares, solar radiation can constantly strip particles from the atmosphere away. So it's mainly why Mars's atmosphere is so thin, because its magnetic field's gone. So now it's at the mercy of the sun, which is constantly stripping its atmosphere away.
Very cool. Mr. Whitbread's class asking, if the moon were to go away tomorrow, what would be the effect on Earth?
Ooh, that's a good question. Well, the change in tides will be gone. We would not have that anymore, which would affect, I think, how some people's livelihoods go about, especially at seaports. I don't know, I don't think it would change ocean currents much. And also it would be very dark. It'll be a lot darker at night now because you no longer have, it's pretty much every time there's a new moon, it'll be like that every night. So you no longer have that natural light available to you. And I think the big thing is just the tides will be gone. We will no longer have high tide or low tide, so it's just going to be pretty still.
Okay. Backing up to an earlier question, and I think this really applies to the lives that astronauts live in space. What time zone do they choose to use?
Oh, it's the time zone. It's the time zone in Houston. So
that would be mountain or something.
yeah, Mountain Daylight Time.
Central.
Yeah, it's Mountain Daylight Time. The only reason they do that is because since all mission control's in Houston, the astronauts should abide by the time of mission control because that's the people they're reaching out to.
Excellent. We have a lot of questions left in the window, but we are getting kind of late in our time. I wanted to ask a little bit more about your group at the Institute. You're somebody who studies lava flows. That maybe isn't the first thing that somebody would think about in somebody who's studying space. So on your team, what kind of scientists are involved in the work that you're doing at the Institute?
Involved in my own work or in general?
Well, in the Institute in general, okay. I suppose.
It's quite an array of different projects. I'm only one of the few actually that focuses on lava flows or volcanism in general. But I also never mentioned this, but I also study some impact craters because they're everywhere on the moon. And if we want to be able to understand surface processes, especially in space, impact craters, like meteorite, if anyone doesn't really know, it's when a meteorite strikes a surface, creates like a giant bowl shape on the ground. That's what an impact crater is. We have other people that study astrobiology, so trying to understand whether life could have or could still survive on Mars, not the moon. We also have people study the glaciers on Mars, mainly like what do their surfaces look like and how can we discover new glaciers or ice that might be buried beneath the surface. We have other people that study also what we call autonomous field work, which is just designing a program where a rover can looks at an outcrop or a rock and is able to automatically identifying it without a scientist having to. So they kind of test the accuracy of that. And we've got an array of different researchers, such as studying different types of craters, understanding the teamwork and communication between scientists and engineers during missions. And also we're trying to branch more into how understanding the physiology of astronauts when they're in the moon and their mental states when they're in, like, especially on the International Space Station, when they're up for 6 months at a time, can take a huge toll on your body and your mind. And we also have a lot of students in physics where they study, once some students have studied how looked into black holes, how stars formed, looked into monitoring cometary orbits. And also we've had some people look at studying solar storms using satellites that orbit the Earth.
So obviously students that are interested in studying or working as part of a space program, they have lots of points of entry into this field.
Yeah, we don't really, the Institute doesn't limit itself to one department. I mean, because even if you came in like, for an example, let's say like you wanted to study law, but you really found space interesting. There's a new thing that they're calling space law. So trying to understand more about space policy, how should countries settle or land appropriately on planetary surfaces? Because there are treaties that say a single country cannot declare property on another planet. That was a treaty that said no country can do that. But then there's the argument that the private sector could, because it's its own entity at that point. So the Institute's hugely interdisciplinary, so you can come in at any angles. Yeah, you're absolutely right. Cool. Even if it's not science. If you came in from an arts background, I don't think, and you had a space themed idea, I think the Institute would definitely take you on.
Very cool. So the last thing I just wanted to touch on is for teachers and students that are on the webinar today to be involved in the Junior Astronaut program. How do they get going?
If you type in Canadian Space Agency Junior Astronauts, you will be able to get sent to their website where teachers and students can make accounts on the website. And there are 3 streams. So the Survivor Moon I showed you, that's on the communication and teamwork stream. There's also a science and technology stream and a health and fitness stream. And what you do is every time you complete one activity from each stream, you'd go on your account and check saying, I completed this activity. So you've checked 1 point off for that stream. If you complete one activity from each stream, you then say you've done that and you have the chance to have either a Canadian astronaut or a science professional come into your classroom to talk about their experiences or any questions that you have for them. And also if you're a student, because teachers can also submit to maybe have a professional and astronaut come in, but the students can also have a chance to attend the Canadian Space Agency Space Camp that they'll be having this summer. I can't remember, I don't know how many they're opening up to, but the website should say how many.
And so the students that complete a certain number of the assignments or the activities, then they can apply to attend Space Camp, and then that decision is made later in the year. Is that right?
Yes. Yeah, I think the deadline is March, I believe.
Fabulous. So as Gavin said, lots more information on the Canadian Space Agency website. Search Canadian Space Agency Junior Astronaut in your browser and you should find lots of information in both English and French. So you can find that there. It's 11:40, so we should, or 11:40 in Eastern time. We just had a conversation about time zones, so I should be clear. Thank you to all the classrooms that joined us today. Gavin, thank you so much for joining us.
Oh, no problem. Thank you for having me.
So this is our last live event for 2019. We will be restarting live events with more junior astronaut sessions in January. That information will be coming out to teachers shortly. Again, thank you for joining us. Have a happy and safe holiday season. Thank you, everybody. Take care.